Imagine a lottery with utterly absurd odds. Instead of picking 6 numbers, you have to correctly guess trillions upon trillions of values, representing the fundamental constants and quantities of the universe. These values determine everything from the strength of gravity to the mass of an electron. Now imagine winning this lottery. That's essentially what happened with our universe. The universe we observe seems to have won this cosmic lottery, with its physical laws and constants precisely set to allow for the existence of stars, galaxies, planets, and ultimately, life itself. This remarkable observation leads us to the profound question of cosmic fine-tuning. Let's consider a concrete example. Imagine trying to build a stable house of cards. The slightest breeze or a minor miscalculation in card placement can bring the entire structure crashing down. Similarly, the existence of a life-permitting universe is contingent upon a delicate balance of physical parameters. Even a tiny shift in these values could render the universe lifeless, devoid of the complexity and beauty we witness today. Fine-tuning refers to the remarkable observation that the fundamental constants and quantities of our universe seem exceptionally well-suited for the emergence of life. Just as a radio needs to be tuned to the correct frequency to receive a signal, our universe seems to be tuned to the precise values that allow for the existence of stars, planets, and the intricate chemistry of life. This apparent fine-tuning has profound implications for our understanding of the cosmos and our place within it. If gravity were slightly stronger, stars would burn out far too quickly for life to evolve. Conversely, if gravity were weaker, stars might not ignite at all, leaving the universe cold and dark. The delicate balance of the fundamental forces seems to be crucial for the emergence of complexity in life as we know it. Our universe is governed by 4 fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Each force plays a crucial role in the cosmic symphony that gives rise to life. Gravity, the weakest of the 4 forces, governs the large-scale structure of the universe, holding together galaxies and solar systems. Electromagnetism, responsible for light, electricity, and magnetism, governs the interactions between charged particles, forming the basis of chemistry, and the bonds that hold atoms together. The strong nuclear force, as its name suggests, is the strongest of the 4 forces, binding protons and neutrons together within the atom's nucleus. Without it, atoms as we know them would not exist. Finally, the weak nuclear force is responsible for certain types of radioactive decay, playing a crucial role in the nuclear reactions that power stars. These 4 forces, each with its unique strength and properties, work in concert to create the conditions necessary for life. The slightest alteration in any of these forces could have resulted in a very different universe, potentially one devoid of stars, planets, and life itself. Section 4. The Big Bang's Balancing Act. Precision in the primordial fireball. The fine-tuning observed in our universe is not limited to the fundamental forces. The initial conditions of the Big Bang, the event that marked the beginning of our universe, also appear to be remarkably fine-tuned. The expansion rate of the early universe, for example, had to be exquisitely balanced. If the expansion were too rapid, matter would have dispersed too quickly for galaxies and stars to form. Conversely, if the expansion were too slow, the universe would have collapsed back in on itself. The homogeneity and isotropy of the early universe, meaning its remarkable uniformity in temperature and density, also pose a puzzle. This uniformity, observed on vast cosmic scales, is difficult to explain given the relatively short time available for different regions of the early universe to reach thermal equilibrium. The initial conditions of the Big Bang, therefore, seem to have played a crucial role in setting the stage for a life-permitting universe. Section 5. Many universes, many possibilities. The multiverse hypothesis. The apparent fine-tuning of our universe has led some scientists to propose the existence of a multiverse, a vast ensemble of universes, each with its own unique set of physical laws and constants. In this scenario, our universe is just one among countless others, each representing a different outcome in the cosmic lottery. Some universes might be too hostile for life, while others might harbor life forms vastly different from our own. The multiverse hypothesis, while speculative, offers a potential explanation for the fine-tuning problem. If there are indeed countless universes, each with different physical laws, it becomes statistically less surprising that we find ourselves in a universe suitable for life. However, the multiverse hypothesis remains highly controversial, as there is currently no direct observational evidence to support it. Critics argue that it introduces unnecessary complexity and that it is at present untestable. Section 6. A Cosmic Designer? The debate surrounding fine-tuning. The fine-tuning of the universe has sparked intense debate among physicists, philosophers, and theologians. Some argue that fine-tuning points towards the existence of a cosmic designer, an intelligent being who fine-tuned the universe for the express purpose of creating life. This view, often associated with religious or spiritual beliefs, suggests that the universe's apparent design implies a designer. Others, however, contend that invoking a designer is an unnecessary step, arguing that natural processes can account for the observed fine-tuning. Proponents of the multiverse hypothesis, for example, argue that chance and probability, rather than design, can explain why we find ourselves in a life-permitting universe. The debate surrounding fine-tuning is complex and multifaceted with no easy answers. It raises profound questions about the nature of the universe, the origin of life, and our place in the grand cosmic scheme. Ultimately, the question of whether fine-tuning implies a designer remains a matter of ongoing scientific and philosophical inquiry. Section 7. A universe tailor-made for us, looking to the future. The fine-tuning of the universe is a profound mystery, one that continues to captivate and challenge our understanding of the cosmos. As we delve deeper into the universe's intricate workings, we are left to ponder the implications of this apparent fine-tuning. Is our existence a cosmic accident, a fortunate outcome in the grand lottery of universes? Or does the universe's remarkable suitability for life point towards a deeper meaning or purpose? As the late physicist John Davies eloquently stated, the very fact that we exist as observers of the universe implies that the universe must be constructed in a very special way. As we continue to explore the cosmos, both through observation and theoretical inquiry, we move closer to unraveling the mysteries of our finely tuned universe and our place within it.